Western.
Slightly different than that, but I'll tell you who I am.
My
presentation.
Okay, yeah. Anyway, it's going to come to, many of you will have heard about the issues we had at Nuneham Viaduct earlier in the year, and he's here tonight to explain what went on and particularly how they actually managed to fix it. So,
Yep.
Over to you, Mike.
Thank you. Yep. So here we go. So first bit. Any idea why this is not working?
No idea. Fact is it not working?
It's all good, isn't it?
It's not working. Oh, you can use your mouse, of course. Move the top screen. That's it. Now, so just click on that email select button. Just click with your mouse.
Yeah.
Oh, yeah, click on the question. Top screen. That's it. Move the cursor around again with the mouse. That's it. Just click on that, and that should work. There you go.
All right. Okay.
No.
I'll go with that one then. So, so it's a bit of a why, who, where, and what, and how. Why am I here? Because Andrew asked me to, and he didn't find any other candidates to talk about Nuneham, but Mr. Marshall, who's a part of the PWI, is over there and knows as much about this scheme as what I do. So thank you for that. A little bit about me, but I'll come on to that in a little bit about who I am. Most people will now know about Nuneham, but there is a lot of people that didn't. It's a small village in Middle England somewhere, between Didcot and Oxford, and probably impacted, let's be honest, nearly everybody in Western Route over the period it was shut. And there's quite a lot of other people that was affected in numerous other routes as well, because of when we shut that down, the diversions that we had to invoke on that. So a lot of the huge amount of the travelling public is affected on, and now know where that plays in. On what about the asset? It was a bit of a sinking feeling that came about, and we'll talk about that. There's a little bit about the asset in terms of triggered old broom, and you'll understand what I mean with respect to that. And then I guess the how do we put it all back together? And was that genius or luck? And I'll let you fathom out whether you think one is more appropriate than the other. Bit of the history on Nuneham. Originally constructed on the top right hand side as an 1840s timber viaduct across the Thames and the floodplain that was there. Didn't last very long as a timber viaduct, and that's not unusual because we've got lots of timber viaducts in the West Country that didn't last very long as well before they started to get rebuilt. Replaced with the metallic structure you see down on the bottom left and the bottom right in the 1850s as a 7-span steel structure on steel trestles, I'm going to say, but I'm not absolutely certain. I think they were steel trestles down onto some form of foundations, and say some form of foundation because we're not absolutely certain what those went down onto. And if you can see in the bottom left-hand corner, there is just the outline of a bit of a wing wall, and that is what was there today. Well, it's not there today, but it was what was there earlier in the year. And then in 1908, the river spans were effectively rebuilt with the 2 trusses that you've seen on the original picture and what was there evident today. And in 1929, it was again modified in terms of the back spans over the land to the north side were turned from some very simple metallic structures to something quite unusual in terms of 1929 arches that we put in. Now, most of the arches we put in obviously date from the 1820s rather than from the 1920s, but for whatever reason, they built 4 land spans with brick arches in there. So it is a bit of a triggers old broom. Some of the stuff was obviously the span length is pretty much the original length, but what the components of it over its lifetime has significantly changed. And then what did that mean for the asset that we had to deal with? Some of that substructure, specifically the substructure to the south side, which is on here, has effectively been reused in many forms. And I say in many forms because we're not absolutely certain what we found when we came to do the works, whether that dates from the 1850 construction, modification in 1908, and subsequent modification. So it was a little bit of a triggers of old broom. Was it a known problem child? Yes. We've had sporadic poor track quality issues over the last 5 years. Certainly on the south side, entering onto the viaduct, there has been numerous bump reports from PUA over the last 5 years. About 5 years ago, they tended to be about a year apart, and they started to be a little, and we thought that, and that was addressed by tamping, just bringing the track back up, and then effectively it went away for another year. And as we moved forward in the last 2 or 3 years, they've been more regular in terms of our bump reports during the day, all traffic on stop. And from that, all traffic on stop, obviously, we've got lots of delay minutes. Back out there, a bit of hand tamping, and being put back into service again. But there's also evidence from about the last 10 years that something's been going on with that asset, because the depth of ballast on the south span is very much deeper than on the north span over the main river. So it's been accumulating ballast depth and interventions over quite a period of time. When you look at the structure in its own right, the deck and all the abutment, there's limited defects in it. So it hasn't broken the back of the abutment, and the structural form, the steelwork, didn't twist or anything like that. So it all looked pretty stable and okay. And the assessment was in date, and there's sufficient capacity in the structure to take RA10 loading at 60 mile an hour, which is what we've got for that part of the route with some of the old coal traffic that used to go down there, and obviously we've still got some stone traffic going down there as well, the likes of Banbury. Geotechnical examinations indicated that there were no specific failures. The embankments weren't pushing out, slipping away, nothing like that. So what was causing the dip in the track on the approach to the abutment was not readily understood. We did some coring through the abutment, which suggested there was some voiding behind it, which we've had on other types of assets where there's been an underground water course or something, taking out fines, removing some of the material behind, and then leaving some voids behind it. So we thought we were dealing with some form of voiding behind, and if we could fill that, then we could potentially give some support to the track profile just immediately behind the abutment. All of this is happening on a railway that is actually operating pretty much on the Didcot to Oxford line as a 24/7 railway, because of the amount of freight that goes up through there. So we needed to come up with some temporary holding solution to stop the track quality issues developing any further. And we had started to be in the area of looking at how we were going to fill the voids, and from that, how we were going to stabilise the structure on a short-term basis. As we've gone through the further bump reports doing, and the sleepers on the behind the abutment being unsupported and dipping, there have been a number of speed restrictions imposed, and it's gone down from 90 to 50 to 20, and we were in the very last part of that 5 mile an hour, and I'll come on to that in a second. Track interventions in terms of putting on extra ballast was causing us a bit of a problem, because the capacity of the deck elements for the cross girders was limited at RA10 at 60. The more ballast that we were putting on, because the structure was going down and tamping and bringing the profile back up, was putting additional weight at that end of the structure, which was taking capacity out of the cross girders, and therefore we were actually at the end of it, we weren't allowing the shoulders to be ballasted, and we were actually taking some ballast off of the deck to be able to just tamp that and put that back in the cribs on the running onto the structure. And beginning of the year, we came up with a solution, which is putting some geopolymer into the ground. Now, the intention of that was to fill some of the voids and strengthen some of the material behind the abutment and also beneath the abutment. That was meant to be within a constrained environment, doing boreholes down from track level to depth and pumping in geopolymer as we came up through, which we started on that. We also put some geopolymer in where we had access before getting the track access through the front of the abutment and into beneath the abutment, and we poured down through and we ejected into that. And the intention of that was to stabilize the track position and stabilize the movement of the abutment, and then from that give us a bit of breathing space about how we would permanently rectify both the alignment of the deck and also the poor track quality, and give more stability for the long-term stability of the track on the approach to it. Both roads have been affected, both the up road and the down road have been affected in equal measure. So it wasn't as though we had a twist or anything like that. We came to the closure point, what we call change of plan, because we've gone from a temporary situation where we were trying to hold things just about and give the ability for the network to run, to the point where we couldn't satisfy that anymore. You can see some photographs there of the track quality leading onto the structure. And in the centre picture, you can see that we're taking ballast away, certainly through the centre. Obviously, it's taken with a distorted lens, so it wasn't quite as bad as that when you're actually up close and personal, but in reality, that is what the train is feeling as you run into it.
How far at the end of the span dropped?
Around about, from its original position, about 550 to 600 mil.
So I've got quite a significant.
And that's over around about 10 years, we think that had reasonably occurred. And over the preceding weeks up to closing it dropped by about another 70 mil. So the picture you see on the left-hand side there of the wing walls, up until around about February of this year, these look relatively intact. There was some minor damage on the top of the brickwork on the top of that, but in terms of these big fractures in here, you can see they were relatively intact. And the big fractures is because the abutment and the bit of the wing wall that's attached to the abutment was going down, and the original wing walls to the side were staying where they were. So effectively, the abutment was going down and ripping itself off the other parts of the wing wall. But this was staying in plane. It stayed vertical. It stayed intact. It wasn't shearing. There was a crack in the middle of it, but it wasn't shearing disproportionately. And all things were remaining in plane, and we thought we had the ability to continue to take the load at that point. We had about 70 mil movement over the weekend when we started drilling into the formation to put geopolymer behind the abutment. To the point where the track was still going off so quickly that we couldn't even hold it at 5 miles an hour because a buffer lock was potentially happening. And Hingsey Yard, which is just up the road from there, was taking lots of short wheelbase freight wagons with low ballast in them and could have had buffer lock and we could have been off. So the decision was made at that point that we couldn't guarantee that no further vertical settlement was occurring, and we couldn't guarantee that we could hold the track at 5 miles an hour. So we shut the railway. Now, when you shut the railway, all hell breaks loose, as you can imagine. So we kind of knew that there was a possibility of this, but we didn't think we'd actually got to that point. So we had the position where we couldn't keep the track quality at 5 miles an hour. Also, by putting the geopolymer in, it hadn't actually stabilised the vertical movement. You could have extrapolated from the graph whether we thought that was going to occur, but it still wasn't occurring. And where all things had remained in verticality with the abutment, there were some signs that the bottom of the abutment was starting to kick out. So we're now in a position that whilst the deck had come down and the abutments had gone down, there was potentially an out of plane force starting to kick the abutment
into the river,
moving towards the river. Yeah. So all of those things concerned is like, we can't actually guarantee that we can run a train over this anymore. And we stopped at that position. I was on holiday. I then made a skedaddle back down to Swindon. I was actually up in North Wales, so it wasn't so far. And then we had all the great and the good come down the next day, asking us a series of meaningful questions. about how we could keep the railway open, how we could modify what the asset so that we could keep the railway open, and any other way that we could keep the railway open. But in reality, we didn't believe that we could operate a safe asset there. We also had a situation whereby we didn't fully understand the safety of the asset in terms of it staying vertical, staying supporting the structure and not putting that in the river. So we had to understand the shock and the impact of that. The business decided to ask numerous different players outside of Network Rail to come and give their opinion. So we didn't quite have the army, but we had the TA come representing them. We had Southampton University representing, give us some insights into what they thought might be some of the issues. We had the ability to explain to some of the exec members the issues that we had, and they could visualize that and see that. And perhaps at the end of the second day, we were in a position that people fully understood the ramifications of a very large asset over the River Thames that was not in a good geometric position. We didn't understand its load paths and we couldn't ensure its integrity. Fortunately, because we'd been doing a geopolymer, we had Balfour Beatty's already on site. Balfour Beatty's were dealing with it in around about £1 million contract position. So they had some, and we had a designer delivering the geopolymer. So again, we had some background information about what the asset was. So it wasn't as though we'd gone completely to a blank canvas. We had already people mobilised. Balfour Beatty's were also dealing with something pretty complex at Paddington Bridge called London Street, which I'm dealing with. And therefore we could bring in some of their complex, the ability to deal with the complex engineering that we're about to deal with rather than the simple minor works, which is where our contract generally was with them. So we could bring in some of their skill base from that. We had the ability to assess some of the options, and there was numerous options that came about. And to then determine a credible plan. Now, when you're faced with this position, what is a credible plan, and did we stick to it? The picture there is our cartoon of what we developed on end of day 2. Is the cartoon of what we developed at the end of day 2 about what we thought the outline program was to get us to a position. And what you may be able to just about work out is it says the 9th of the 6th there, which is the date that we stated within somewhere in the region of about 48 hours, 72 hours of being in the position of stopping the railway, of when we thought we'd be able to put it back. And pretty much the cartoon, and I'm not going to go through all the details of the cartoon. The cartoon was our base plan, and we kept coming back to it and referring to it. And that led us down a path to get to an end solution. Now, the cartoon was not created by an individual, it was created by numerous people on site. And it was a relatively small team on site looking at some of the issues that we had to deal with. We had a credible designer, we had some credible contractors who had worked in similar types of issues, could bring something together and Network Rail, and we could understand how we thought some of the programming worked. So we had a credible plan. We had to stress test that with limited knowledge because we didn't know fully the ground conditions. We didn't know some of the timelines to deliver these things. We didn't even know some of the materials that we were going to use to actually come up with the final solution. And we had to agree the way forward. And Andrew Haynes came down on, this was on the Tuesday that we stopped the railway, and he came down. So we had lots of people around there on the Monday evening we stopped it. And on Tuesday we had lots of the great and the good come down. And then finally on Friday we had Andrew Haynes came down. So 3 or 4 days in. And we had 2 options at that point. Giving back a temporary railway or give back a permanent railway. And by a temporary railway, we knew that the abutment was substandard, would never be able to be truly modified to be able to take the load into the long term because we didn't really know what was going on with it. Or we could come up with some form of Heath Robinson approach to how we get the loads out of the deck onto something else in a temporary way. Now, the temporary way that we could look at it, we thought we had probably around about a 6 or 7 week closure of the railway. And the permanent works, we thought we'd have a 9-week closure of the railway, which is that effective end date of 9th of June. And if coming back from the temporary and then putting the permanent back in the future, we reckon that would probably take 5 or 6 weeks anyway. So you had a 2-stage approach, which could take you into the realms of 11 or 12 weeks, or a single stage, go for it, go for a big hit and shut the railway for 9 weeks. And that was agreed as the way forward, which made life easy because we could then start thinking about what is the permanent works for the abutment rather than coming up with a lot of solutions that didn't really work. And then the intention from there on in is this: we're going permanent works. We had to stabilise the structure because if that deck had fallen into the water, the 9-week closure would have taken a lot longer.
Yeah, and you wouldn't have been very. The navigation wouldn't have been too.
Navigation, but we'd have been picking up pieces out of the water and trying to put it all together and putting back a deck superstructure that would have been probably unsalvageable because it would have twisted and failed in a manner that wouldn't have been able to be reused.
Yeah.
So we would have then been building or fabricating a new structure, which just exacerbated the situation even worse. So we set about track out, removing the dead load, pictures with machines taking out the panels. They had to transit over the bridge. So we have concerns there that we're transiting on a bridge that we know is not in a good position and failed. A little bit of safeguarding, I guess, that actually the day before or a couple of days before, we were in a position that we were running 100-ton freight wagons over it. So putting some of the red rail vehicles may be okay, but we still have to assess some of that, think about it, try to do methodologies so it's safe. And then we started vacuuming off the ballast, and we removed probably around about 70 to 80 tons worth of ballast because actually, and this is a picture from the centre of the river, effectively over the central pier, looking back towards the south onto the land span. Here we had around about 300 or 400 mil of ballast down to the deck plate, and at the far end, because of the way it had been dipped, we were nearly up to around 700 or 800 mil of ballast on the far end.
It's not
Because the deck had just been going down, and every time it had gone down, effectively the ballast level had been cranked up to create a running in. So we had 2 big vacuum machines down in the on the land down by the river with all the hoses that came up, and effectively we then vacuumed that off. A lot of the ballast at the bottom was still impacted in the bitumen that was there on the deck plate, but we got a lot of the load off. Taking the load off, the abutment no longer settled. So stopping the trains and taking that load off, we then had some stability in the abutment. The abutment was no longer sinking. And from that, we also, by taking that load off, one of the things that we had to do was effectively just hold that deck up, because we knew that we had to have a second means of holding the deck up because we were going to effectively work on the abutment. So removing that load reduced the requirements of whatever our temporary works was to hold the deck up. To hold the deck up would have been nice if we'd have had a nice bit of ground to be able to build a new abutment or something permanent, something that could take heavy load, but the only thing in front of the abutment was the river. So we're now in a situation where we are trying to work over the water, which needed some specialist equipment. We've been fortunate that Timoth Marine Services, who did a lot of work down in the Dawlish works for us and other river works, we could get them on board fairly quickly. They had access to quite a few bits of kit in terms of pontoons, boats, and the walkway pontoon, segmental pontoons that you can see there, but they also had some larger weight stuff that we could bring in equipment onto. We got agreement from the EA that we could close obviously one of the spans down from a navigation perspective. The other one had to be left open. And over the first couple of days, we were actually, we had very high flows through there because this was in April 23. We had very high flows through the river, and the river went up and down by about 300 or 400 mil as well. So we were trying to work with understanding how we could actually mobilise in and around that area with fairly high flow rates through it. The solution that is starting to be in a position is that we had to put some form of foundation in the river. Initially, we were looking at doing a load of screw piles in there and trying to take the load into the ground through screw piles. Screw piles are easy to access, easy to put into the ground. but their actual physical load capacity, because in reality, the screw pile in the ground is okay, but the tube that comes out of it was the weak point in all of this. So we started off down a route where we were going to put a load of screw piles in. That rapidly came out that was going to take longer and longer to modify the top areas of that to get the relative strength in it, that we decided to move away from that option and put in a series of cluster of piles outside of the shadow of the bridge deck, because that's where we need the piling platforms to be able to put it outside of the shadow. So either side of the deck is where we then put these cluster of piles being driven in. Piles were then prepared with a pile cap, which you can see here, to be able to take the next part of that, which is effectively the framing devices that would then span underneath the bridge that we should get this back off. So we then got the pile caps with a collection beam on the top of that, and the same over the other side. In order to be able to manoeuvre the maybe system, which came as a kit part, so this all came on relatively small wagons, built up as a series of kits of parts, down in the compound, and then swung around out onto a barge underneath the bridge, and then it needed to be lifted and cradled onto the pile caps that you can see there. I think that's the best part of a 1,000-ton crane, and we were trying to put it on part of a floodplain. So the amount of preparation work, so every time that we started to get bigger kit, we then ended up doing more and more preparation work to be able to make certain that we could actually keep that thing level on the ground. So the amount of stone that we brought in, all these bog mats that came in now, for every step forward you're coming up with a solution, you were coming up with 3 steps behind it that you had to do more and more prep work to be able to get that solution mode into site. So a huge amount of materials were then starting to come down. That crane cost us around about 150k just for the mobilisation of this part of the elements of the work, and you'll see a picture later. We had to come back and use it again, so some significant cost.
No, just to get the big crane, just to
Just literally move it off a barge, which you can see in the background there.
Yeah.
There's a barge there, literally just to lift it.
Yeah. Like I said,
500 or 600 mil forward onto the pads, because there was no way of sliding it off the barge because the water was obviously going up and down. To be able to lift it off that, tease it in, and then drop it down. Which you can then see that it's actually spanning either side of it. That's the double lifting. Either side of that maybe is then being system is being loaded in. So we're then into a position where we've got the baby system in place. Now, if you consider all of these things, it all seems relatively straightforward. We had a different design function that was designing the piles, another team that was coming up and fabricating and understanding all of these geometrically, how they were going to fit in. And we also had maybe then coming in with a system whereby they were going to have to design something in between all of this, and then took the load of the bridge, of which we could try to quantify relatively what we thought the load of the bridge was after we removed some of the balance, but there were still some inaccuracies in that. The span of this arrangement underneath the bridge and the span of this only just about worked. No, there was very little fat in that system by the end of it. We had a number of design meetings whereby lots of activity was doing on site, and there was one where we took ourselves away from the site offices, went to a hotel, and we spent the best part of half a day going through the individual activities, talking to each other, stress testing, checking on what it is that we knew, and then setting somebody off in motion. And I think if we'd have been in the compound trying to do that, it probably wouldn't work because of the amount of other noise that we'd have had in there. But actually putting somebody, taking ourselves away, doing it in a relatively controlled manner, asking each other some very sensible questions, meant that we did have a credible plan to actually stabilise the structure. From here, you can see that the maybe systems are in place underneath the end of the deck. We've got some props that have gone in, and then it's jacked up. And in the final position you're in, you can see that the deck is actually disconnected now from the original abutment and actually being brought up into a coplanar. So it's the same plane as what the original was, and that's around about where the lift of 600 mil is. So there wasn't any any breaking down of the abutment there. There's effectively just resetting it back to where we're. Talked about beams being within the limits, and they deflected around about 70 mil downwards. When we were jacking them up, they were still going down, but effectively they stabilised, lifted the deck. The loading points of the jacks onto the structure were relatively okay because we managed to lock them onto the cross girders, which had a fair bit of capacity into them, which then went straight into the truss. A little bit of modification needed to be done on the central girder, on this girder, just because actually where the jacks were going to go weren't where some of the stiffeners were. So we could have just ended up just crushing the bottom of it, but we did some bit of modification on that. The bearings that were on the original structure didn't come away on the first time they were jacked. They were still trying to lock themselves in. So we were over jacking it at one point, but a little bit of a jackhammer sorted that out. And then you can see in the bottom right hand picture, there's some services. So actually there's a fibre optic went, and if that fibre optic hadn't been there, at one point we were considering lifting the whole deck out and just dealing with it in a different way. But the fibre optic couldn't actually be shut down, unfortunately. And at this point, we're effectively just over 4 weeks in, and we now have stability of the asset. So out of the 9-week programme, we're 4 weeks in, and we've stopped going backwards, and we can start to go forward and transition on to the abutment works, the permanent works from here on in. Now, obviously, the design of some of this abutment works doesn't start at that point. It started 2 or 3 weeks back, but the first 2 or 3 weeks was clearly all of the design and technical and challenging was all about trying to get that deck stabilized. But if we stopped at that point and then moved into the abutment part of the works, you needed somebody thinking about the 3 weeks ahead. So we were also part of the design team, myself and Phil, is looking into what is the permanent works we were needing to do. The pictures of some of the demolition of the abutment. Easy enough to get relative to machines and some lightweight machines in there and start taking down the brickwork abutment that was holding the original asset up. You can see that we've got it down to ground level, as effectively this is almost at river level bottom of foundations. We can't actually confirm what the foundation type was for the original abutment. We got some evidence that there were some timber piles in here, because when we were excavating, we snapped off the top of those and drew a couple out, which were in relatively good condition, the ones that we could get to and see. And as you see, when it comes to the permanent solution, we went down through that foundation area, but we didn't encounter a lot of resistance. So when I talked about the 1856 structure being on timber piles, it was probably modified, well, the steel structure was then modified onto those timber piles, and the 1908 was probably modified onto those timber piles. So we've effectively got larger and larger deck spans, higher and higher weight, being added on to something that we had no knowledge of, which was probably
So it was
never envisaged.
timber piles just driven into the alluvium.
Driven into alluvium, which probably to a set.
Yeah.
And after a period of time, for whatever reasons, we've overloaded that. And then it's got to the stage of it's given up. Obviously, the services we had to put up on a cable, and these machines and whatever other machines we were dealing with were having to limbo underneath that space. Now we're into the permanent works, and you can see the size of the compound that started to develop down here, and all the bog mats that are in place, and all of the piling platforms. Piles that we drove in, Phil, were around about 15 to 18 metres, weren't they, for the permanents?
Sounds about right.
Yeah.
Prepare for this.
Yeah, they were fairly long, and we had driving in segments. The piling rigs that you can see on the right hand side there had the limbo underneath and be able to then put themselves up. And of course, they're a lot heavier than any of the ground that we found in this area. And so again, a huge amount of preparation to actually put the bog mats down. There were 3 or 4 with a metre of material in between before we'd even get close to having confidence that those piling rigs wouldn't actually turn over. Now, one of the original designs suggested that we were going to put a new abutment behind the original one and therefore have some form of cantilever out to hold the original deck up. Not my choice of design at all because of the way that it would work with cantilevers and everything being in tension 99% of the time. So we were then in a position that we were trying to look at using the existing shadow of the abutment and trying to put something down. But the problem was that the trusses come out, that's where the bearings are. So we couldn't use that space because you can't get underneath the bearings with the headrooms that we had. So in reality, we had a series of piles that sat in between the trusses. So you had two piles on the outside one, effectively a four set of piles holding the centre load, which obviously got twice as much weight because it's got half the deck on each side, and another set of two piles that are holding outside of the upstream truss. And from that, part of being able to get into that space, also that the original deck would have had its deck plate on, which came all the way out onto the abutment, so we couldn't pass through a deck plate. We actually modified and we took part of the deck plate out of the original structure. So that gave us that working window to be able to go down through that space, down through the original alignment of the abutment, right down to the good competent ground underneath. So we've now got a 2023 steel piled abutment on the alignment of the original 1856 or 1840s timber structure. When we're designing these piles, they were only effectively taking vertical load because we have no confidence about them. The articulation of the structure is actually on the central pier, it's fixed and not on here. But we then got braking loads coming into it, and we know that these were going down 20 metres, but we've figured that going down 20 metres is fine, but the top 5 metres of it, top 4 would have been out the ground, and the next 2 or 3 was in some very crap material. So whatever it is, you've got a large amount of momentum going onto those. We needed something else to actually hold back the embankment material. So those 8 piles are only taking the vertical load in reality, and we needed something else to hold back the embankment material. And that's where you can see here that we've effectively got what looks like a cofferdam, but in reality is sheet piles on the sides, and then we've got box piles, and you'll see another picture in a minute of holding material behind the abutment, which is effectively holding back the embankment. Bringing in the backfill, you can see that there were some big rollers that we used when we had the headroom and be able to do it. You're starting to get into the position where we start to come up towards where the cables are. The headroom for the big rollers couldn't be taken. We had to then use into smaller rollers, and then we had to use into whacker plates to be able to get underneath this area as well. So all of this time, you know, the cable route is actually a problem in terms of transmitting material into where we needed to. Compaction of it is also a problem as well because we're working in that space. Although having said that, 2/3 of the area we could reasonably easily access from the river compound. Brought up in 100 mm layers, continuously tamped, and we were doing density tests on that. So if that bit ever fails again, Mr. Bartlett, I will be extremely surprised. This bit just about here will probably go, but that bit there ain't going anywhere.
Properly engineered.
Properly engineered, yes. Yeah, it can't. I can guarantee it can't go anywhere.
It used to be called belt and braces.
Yeah. So this is just coming up towards the end where you can see modified new steelwork on the end of the original deck plate that we cut out. The line of the new piles is through here. This is where I mean about these box piles holding back the abutment. Very useful things to come off and to get hold of. And they were nicked off HS2. HS2 had a series of them in a compound where they weren't using them. We borrowed them. And all of this was a case of we needed material that we could get our hands on very, very quickly. And solutions to understanding where those materials were and did they do what we needed them to do. And I'll just say, did they do what we needed them to do? Because you can finesse some of this design, but every time we were finessing it, we were losing days.
Yeah.
So most of all of this is very, very robust. Still dead, still in grotty condition, and it's still in grotty condition now, but we've got bits of new steel work on it. This is what I mean about trigger broom. So there's 2 issues to that. Trigger broom in terms of modification to the original asset over its period of times, 1840s, 1850s, 1908, 1929. But we've also got parts of new steelwork on old steelwork. To modern standards compared to old standards, to RA capabilities compared to Euro codes, and all of those design issues that come into being. When is a bridge not a bridge? When is an element a new element versus an old element? Lots of decisions and pragmatic decisions made by me with respect to what we needed to do on that in that space, because otherwise we could have had designers running around in circles. And then finally, you can see that we've effectively closed off the box beams, the box columns, starting to close out the deck plate from here, and then ultimately the ballast will start to come back in. And at this point, we're heading towards the 9th of the 6th, so we are still on plan
Did
to.
you fill the box piles or
No.
they just left?
No, these are left open.
Right.
They didn't need that because of the way that they're shaped, so they've got the integrity and stuff like that. We also had the ability that we could have actually filled the circular piles as well. We could have put concrete in those, which would then made them more corrosion resistant from inside.
Yeah.
But one of my questions, one of my challenges was, do I build this for 120-year design life? Well, that's probably got about another 40-year design life.
Hmm.
So at what point do you make this
Yeah.
the same sort of fragility, age,
Yeah.
utilization of what the parent asset is? Because there was talk about this should be a 120-year design life, it'd be more viable for the next structure that comes onto it. Well, I don't know what that looks like. I don't know what I can cater for that. So we actually we're pretty pragmatic about making this suit the parent asset, as it were. And then you've got some geotextile, geocell going in, which allows for the transition to work. As I say, you've got a fairly hard transition in there. P-way being brought back up, and your PW, P-way stuff going in. Don't ask me what sleepers they are. I have no idea. But I can tell you all the nuances of the structure itself. Most of that was relatively new stuff that was coming in, because I don't think we reused some of it. We had logistics that we were coming in and being serviced to the top yard and being brought down. The McCullochs were nicked off a job up in Scotland, so I think they had a 2-day delay on some program that's up there. So we were impacting other parts of the network in terms of nicking their plant to be able to put stuff back together again. Dropping routes going in for putting the cables back in for the fibre optics. And then we have the effectively decent P-way that's back in, and the first train that ran. And that ran on the Thursday morning of the 8th. So we effectively handed it back to the route on 1900 on the 7th, which is the Wednesday. The intention was to hand it back on the Friday. On Thursday morning, we managed to, with GWR's assistance, roster one of their trains that went up and down, did a improving run through it, and therefore we handed back to route early doors on the 8th, and then service resumed. Majority of service resumed on the 9th, which is the day we handed it back. We missed an opportunity, or constrained ourselves with an opportunity, in order to give something like this back after you've had a 9-day closure. The route needed at least 4 days notice of when they could run their first train. We were still putting in, as you can see from the previous stuff, we were still bringing up the embankment 4 days previously. We had no real surety that we could have done all of the P-way testing, all the signalling testing, and everything else was going on. So we couldn't give that 4 days notice. And hence we didn't be able to run a full recovery service on the 9th. But we gave it back to the route.
Which certainly looks a lot happier now, doesn't it?
Yes. We had to bring back the big train again, because we had to move these things back off their temporary support, back into the river, take them back out again and off-hire them. And so we had a couple of weeks later, we were in that position of demobilising. And we had to demobilise all of the compound area down here with all the temporary works and give that back to the EA. The haul road had gone up and down quite a few times. The compound, which started off as around about 3 cabins, then grew to a city And from that city then grew a huge spoil heap where all old materials going in and new materials going out. We had access ways over the fields for about a mile down here to go out. So we're then starting to demobilise and decamp all of this. And eventually is round about the middle of September that we've effectively closed the site down, done all the last bit of palisade fencing, and walked out of there and handed it back towards the farmer. Why did it work? Well, I think it did work. The team were already partially mobilised, so we knew who we were dealing with. Constructor had the experience of complex works and could bring that to the table, rather than actually using the wrong contractor.
That mean they also had access to the kit as well?
They had access to their wider parts of the business that could call on that quite quickly.
Yeah.
We had very much the top level team of those contractors coming down and were effectively asked, is there anything you need from us? And apart from an open checkbook, they said no. In which case, can you make sure that you give us every opportunity to get this over the line? So they called in lots of favours across their higher level business and made that as a clear focus. We acted as a single team and it was small and compact. And if you consider the amount of people that were on from Network Rail, there were 3 primary individuals from Network Rail, myself, Phil and Claudia Phillips. The Belfast team had 3 or 4 people at high level that sat there nearly all of the time that we were shut for 9 weeks. We had 2 or 3 design people that we interfaced with. And from that little core team where everybody was on the same page nearly all of the same time, that was where the dissemination of information came from. We separated out the activities and the skill set, so I didn't start dealing with any of the project management stuff, and Claudia, who's the project manager for Network Rail, didn't deal with any of the technical stuff. So we left ourselves to deal with what we needed to do. We kept each other informed about where the risks were, but we separated ourselves out from that. The materials we used were all off the shelf and readily available. Most of the piles went in were 760s or 610s, and we tried to nick those wherever we can from OHLE works. So going and scouring around Morton Yard and other places to get as many of those. I think at one point we were going to nick them off the Core Valley lines as well, because they had some going. So we were at one point going to nick them from there. As I say, the box sections for the abutment we nicked off HS2. We had a fairly robust temporary and permanent designs, so we mapped them out and we made certain that there's plenty of fat in the designs for them and they weren't skinny, and we got progressive agreement from Network Rail through the designer, through if it was a temporary works contractor or from the material suppliers, about how we signed those off as we were incrementally building the solution mode up. We managed the project and the information streams separately. So whilst I got involved in some of the issues with the loss adjusters and the technical side of that, and Claudia got slightly involved in some of the sort of the stuff reporting up internally. Most of the high level stuff to exec was all done by Stuart Calvert. So that was completely away from us. We had the air cover that we weren't being pulled in different positions. And the key thing for me was that everybody had to focus on the end state. And we actually, even within that, we managed resources. So the Alpha BT's contracts manager actually on 2 occasions had weekends away. One of them we went to Magaluf and got absolutely hammered on the stag do and came back. And then there's another one where it was his wife's 40th or whatever, and he went away somewhere else. We had the ability within the resources that we didn't burn ourselves out. If it had been more than 9 weeks, I think we would have struggled. But as it was, we got to the end state that everybody was focused on it. So from my perspective, those are some of the reasons why it worked. Some of the players in that Belfast BTs there was the principal contractor, Craig Walker, the main designer. TMS Marine did all of the works in the river. Dawson provided most of the steel work, maybe higher Protec. Structural soils, we were limited in ground information, so we had to call them in very, very quickly to confirm all the ground information to get the pile design to work. MJ Hughes did most of all the steelwork fabrication and dealing with all that. Force One did some of the vacuuming of the ballast and the likes of that in Sunbed and Cullex. So very much without any of those, we would have really, really struggled because everybody was working to the same program, everybody working to the same mentality, and each of those cogs all fitted together seamlessly. So really very fortunate in that. And that's Nuneham Viaduct for you in a nutshell.
Right, I'm sure there's some more questions. Is there any questions online?
No, not on that.
Right, nice.
There's a lot of people online.
I'll throw it open to the room now, any, so.
What do you think initiated the final series of failure? Because they've been there a long time before it suddenly, I can see why the rate of sinking would settle because there was
Yeah.
more ballast going on.
We were putting more ballast on, so we were exacerbating the situation by every time we had a minor fault, we were actually making it worse.
What do you think triggered that though?
I still don't know why, and even when we were going through the loss adjuster said, if you can prove to me it was an environmental issue, then I can give you some money. If you can just prove to me that if you can't do that, then in some respect it's a settlement issue of which is within your sort of our internal insurance. So we didn't get any money. But we couldn't find what the trigger was. Now, if you look at, you could say, oh, we got more loading on it. No, we've only got container traffic on it, realistically. Now, we had lots of aggregates on it once upon a time, but we haven't got now. We had all the coal traffic going to Didcot 15 years ago that was hammering hell out of it. Whether that started it, don't know. But there's no one thing. There was a water pipe on the upstream side that burst. That was a water feed for Thames Water. Happened about 6 years ago. Did it actually increase some of the moisture levels at lower level that started to trigger something? But we couldn't find an independent activity that created this is what started it. You the same opinion, Phil?
I wouldn't disagree with anything you're saying. I do wonder when they started injecting the polymer, whether it changed the flow paths in the ground and you got pore pressures building up, and that was I'm guessing. I mean,
we had and that's why we were hoping the polymer would stabilise to give us something, but it may have inadvertently triggered the next level of it that meant that it was unrecoverable at that point. Yeah. So
I think I might have said that the polymer injection is quite a new technique.
it's a new technique and can be used in embankments and stuff like that to provide some form of additional support to them. Whether it was used appropriately or not, with respect to an abutment that's already settling. Had we had really good access and stuff like that, we'd have gone for some form of piling or micro piling technique in and around it. But in reality, you've got water in front of you on one side, you've got a big railway on the other side. You can't get plant in there to be able to do a sort of a physical intervention, and that's why we were going for some form of ground improvement to try and stabilise that.
Alex.
Hi, yes, sorry, what do you do with the piles in the river?
We got agreement from the EA. We were thinking that we were going to have to actually take them out, but we actually cut them off 300 mil below bed level. So because they're close up relative to the abutment and the training board, there's a view that actually craft aren't actually going to be that close to it, but we did cut them off below, burn them off below bed level. So there is still 10 metres of piles and times 8 times 2.
If you're ever desperate for
If
it.
you're looking for them.
Well.
We can use for the next time it goes wrong.
Yeah, when they eventually get quite wrong, so you might want.
Yeah.
Great.
I was slightly confused with one thing. When your very first slide, where you showed the original bridges. They appeared to be significantly longer than the 2-span bridge that's there at the moment.
What that picture is effectively the 2 river spans, and then you've got 4 flood arches behind all the vegetation, obviously in those lithographics or whatever. It didn't have vegetation apparently in the 1850s. If you have a look at every bridge photograph you ever see, there is no trees or vegetation compared to the network that we have these days.
So you had there are more spans than behind the 2 that are on all your pictures.
Yes, yeah. There's 4 flood arches to the north side. Yeah. So
Those were the
which was all there is no problem in that space at all. The centre pier, we think, was a new built centre pier for the new structure.
Yeah.
And the north span where that truss landed, we think was a new built pier.
Yeah.
And then they reused the south span pier, south span abutment, which is why we think is effectively it was always under capacity.
With props, perhaps not fully understanding.
And not what that foundation solution was that was originally used and whether it was actually appropriate for the 1908 modification with the trusses.
That's
It would have taken as well, a heavy load.
It's taken more dead load in terms of just total span length onto it. But how it was proven, I don't think we actually take that, I have no idea.
Stephen Long online asks, when removing the dead load, was there a need to control the rate and locations of removal to manage the load distribution?
Panels came off at the same time, and in terms of ballast coming off, we did have two machines working, one on each road, as it were, and they were working back from the centre pier back towards the abutment. So we didn't effectively strip one that effectively would have twisted the deck or anything like that. We came back at the same rate. I wouldn't say that we brought them back exactly uniform, but in reality, we brought them back at the same location to be able to take that ballast off. Yeah. Now, all of this, just so you're aware, has cost the business circa about 50 million. I say circa 50 million. In terms of the physical works, in terms of what we put in the ground, around about 15 to 17 million pound. And business impact is around about 35 million pound. Now, we were we understood what that magnitude was quite early doors. And the reason for that was I was involved in Dawlish many, many years ago when we shut the railway down there for 7 or 8 weeks. And we knew what that sort of order of cost would be. And when you get into this sort of thing, we knew what order of cost was. So we had a focus that in reality, we were burning best part of £1 million, £750,000 a day, every day that we were keeping it shut. So when it started to come to engineering decisions or finance decisions and stuff like that, so if you can save me a day, you can save me £750,000 to business.
Yeah.
So it makes it easier to make those decisions.
Yeah, it's just a get on with it.
Yeah, so get on with it, as it were, and then sort of like use that mentality to say, if you can save me a day, we're going to save a day. If you can guarantee me that we can get it to the end date, then we still do it.
Yeah.
Which is why we came off of the screw piles very, very quickly and went into something that we possibly a slightly higher risk, but still got to the end solution.
Do you think the small team actually help keep that focus? Because I've often found when we get these big things, you get everyone and their bloody dog wanting to
Yes.
come and interfere and say what you're doing and suggesting ideas, not the rest of it. So,
Yeah, very much okay. So I'm the head of engineering for buildings and structures in Network Rail. So my level within the region means that I have authority to sort of say what I want done. I have the ability that I've worked in this very much an emergency situation with Dawlish before and understand the dynamics of how that then becomes decision-making processes as you work through.
Yeah.
We fortunately had Jane Austen and Stuart giving us air cover to the exec to say, actually, we do know what we're doing. We've got a reasonably credible plan. We've got the confidence to be able to go and do it now. Let's go and do it.
Yeah, so they provided the sort of outward face and updates.
If we hadn't come up with something incredible and we were continually back working and losing those first 3 or 4 weeks of being able to get and stabilise the structure, then I think other people would have started to come in. But we had a credible plan. We knew the limits of each other and we made some very pragmatic, rounded decisions and set ourselves in motion quite quickly.
Engineering in the raw. Yes.
Engineering very much in the raw, yes.
Okay, right. Any other questions?
Did I notice there was, did you have to do any works at the central pier? Was there some damage?
The only thing in terms of the central pier, because the south side span had dropped, it was crushing the front of the brickwork, and when you lifted it back up, we still had some crushed brickwork in there. So we put some steel work in there just to clamp that bit of the brickwork to go out. It actually reduced all of that crushing there because it had come down by 600 mil and effectively really crushed the front of the pit.
Oh,
has there been any substance of the South Pit since you reopened the railway?
No. The only thing that I would say is that we some further traces with the track recording, and there's it was slightly going off, but we think that's more consolidation in the top ballast than anything else. And there was a follow-up tap, I think, either a couple of weeks back, just to get that back. But it didn't require any TSR down from the 90 that we effectively left it at. It's effectively within the limits of that, but we've just topped that back up.
So what time speed have you got there now?
It's 90.
90.
Yeah.
just backward.
Which is back where it should be. Yeah.
Yeah.
Yes.
It's not uncommon to find a bit of settlement off the end of a structure because you're obviously running from a quite a stiff structure onto an earthwork. So there will be some consolidation in that. over
Did
time.
you open it?
I think we opened it at 50. Just to give ourselves that little bit of working space.
Yes, yeah.
You've gone from 0 to 50, they're really quite happy.
Yeah.
Because they've been living with it at 20s and 5s for quite a bit as well.
Yes.
So we then just followed it up, I think 3 weeks later with a tamp that took it with 90. And then there's been that follow-up phrase that just says, actually, can we just top that?
Right, any more questions? Right, okay, well, in that case, I'd like to call upon Graham to propose a vote of thanks.
Not a problem. One of the easiest votes of thanks, I have to say, you've been asked to give. That was one of the most interesting and best presentations I think I've seen here in a long, long time. Now you asked us to decide whether it was genius or luck. Well, I decided that about halfway through. Yeah, and that was not luck. That was very clear to me. I think probably it's an example of engineering at its best. All the way through the presentation, the logic was irrefutable. I felt as I thought before, you answered the question that I would have asked. One thing was very clear as well. It was in slide 7. You threw pictures of the bridge as it was when you started the work. The right hand of those pictures was incredibly clear just how far that bridge had gone down. When Andy asked the question, if you just extrapolated the line across the original structure, you know, it was so obvious how far it had gone. I think it just proves again that that when we're under pressure as railway engineers, we excel. Thank you. Cool.
Yes, it shows why the world needs engineers, doesn't it?
Hopefully not too often.
Well, not like that, no, but, okay, right. So the minutes of the last meeting went round. They came out with the notice. Are there any issues arising from that? Be a first if there is. Right, okay. It's good. So the next meeting will be on Monday, the 11th of December. And it's about basalt reinforcement in the railway industry with Malcolm Newton from BASTEC. So the next item on the agenda says adjourn to the Prince of Wales. And the Prince of Wales is shut, isn't it? I think at the moment. Yeah. But you have to go to the Great Western. So we will adjourn to the Great Western afterwards. Okay. Right. Is there any further business?
Just one observation, travelling back from Manchester today to Newport, I couldn't but help notice that virtually all the fields you look at through the train window seem to have some sort of water line there.
Yeah.
The small amounts or large amounts.
Yeah.
Obviously, it varies from field to field, but it just shows the amount of water there is in the ground surrounding the railway.
Yeah, we've had a lot of trouble with flooding at Wootton Bassett and places like that, which perennially flood. Yeah, the trouble is by the time it floods there's nowhere to send the water. You know, so because the local rivers are now full.
More serious than that, the golf course is shut as well.
Well,
This is coming by a crew in Shrewsbury. All that floats.
okay, right, with that, I will declare the meeting closed. Thank you very much for your time. Thanks for those online.
Yes, they passed their thanks on.
That's great.
Lots of them.
It did, indeed, yes. So Jane is was the dean, so director of engineering.
Was it?
Yeah. She's taken this one.
Changing it, that's all the.
It's online tonight.
So she would be there if I was in the region. And I was there. I came up and.
Stop recording. Have you stopped recording?
No, the PWI membership secretary was.
She got many years to go. I think it's only happened to double tell it, but.
Oh, sorry.
I think they interviewed my son.
Thanks.
One of my old inspectors was.
25.
It was fine. 25. You wanted the bottom man cost me like that time to take a rest.
You need to see the.
Yeah, the time field. So, women engineers have come a long way since then, we've come about 30 years ago.
It started off and unfortunately, about halfway through.
So you get two now. I'll be down tomorrow.
Oh, yeah.
I know.
So once you got it back. In the trenches, for 4 weeks. Challenging change. Asking questions.
I worked for the PA, started talking to her, and they won't tell us about it.
Yes.